Hello. The following video is a recording from our astrophotography workshop held within MetaJungle Discord on January 13th. This series is very helpful for aspiring astrophotographers and is taught by Mustafa Aydin, an active MetaJungle Discord member and also a very talented astrophotographer. This is the second in our series, and we have Milkyway photography, and this series is covering planning and also camera settings, so very important details. The different websites that are mentioned throughout the workshop are linked in the description below, so please check those out. Also, we hope you can join us in the MetaJungle community. There's lots of free and helpful resources to help us navigate the NFT space.
So today we are having the part 2 in Milkyway photography. It's planning. It has 2 parts today, the planning and the shooting settings. Let's start with part A, planning, which is extremely crucial to plan astrophotography sessions, because it's not like you cannot grab your camera and your gear and you can head out and start shooting, because there are some points that I'm going to be explaining tonight. Beforehand, you have to plan your shooting session very well. And we have like pre-planning, preparation for the astrophotography session, location scouting, and actually location scouting and outdoor planning is more like the same. There are these steps which has to be taken. So we have to know that within a year, the night sky is constantly changing. So if you are on a fixed location, you will see that night sky will change from day to day, and in seasons the change will be more dramatical. For instance, we cannot see Milky Way between November and February. So because of the rotation of Earth around the Sun, and also the 23 degrees of axis change, makes us not to see the night sky. For this, we use Stellarium program, and I will show it in a bit how it works. It is actually a simulation of night sky. You can go anywhere on Earth with the name of the city or with the GPS coordinates. You can go at any date and time, so that you can see how the sky will look like when you are at that certain point, at that certain day and certain time. And another thing, we have to watch the moon phase. I will explain. There are websites and there are some applications that you can watch the moon phase. We cannot shoot Milky Way during full moon, and also before and after the full moon. So I will explain more. And light pollution is very important issue. If there is a light pollution where you're going to shoot, your camera sensor will be filled with light from the light pollution instead of light from the celestial objects, and the celestial objects will be washed out and you will not be able to shoot them if you are in a light polluted area. There are applications and also web-based light pollution maps that you can use before you're going outside when you're planning to shoot Milky Way. You can see the certain point on the map about the light pollution. And of course, weather forecast is very important. You have to watch weather forecast from different resources. And at least for last 2 weeks, and you will see most of the time, sometimes the weather will change, the forecast will change, and when you are closer to the date, it will get more certain, but still it is forecast, so it is not 100% reliable. And of course, knowing your equipment in pre-planning, it's so important. Because you're always at night, outside at night. You have to know your camera. You have to know where are the buttons for which function, so that you can adjust your camera in the dark as if it is daytime. And there are some certain settings that you can set before you go out, but it is always good to know your camera, because every time something might happen, and you have to know how to fix it. And equipment checklist. There has always to be a checklist, and I will show you a sample of checklist here. And you have to make checklist all the time, and you have to improve your checklist because you will see that even though you have a checklist, you will be missing or you will be forgetting stuff. So every time you go outside and every time you realize that there's something wrong with your checklist, you have to improve it. You have to change it. Okay, let's start with planning softwares and applications. This is extremely great application as a program. It is free for computers, PCs, and it has some free functions for iOS and other telephone operating systems. So we will get to this. Google Maps or Google Earth, whichever you like. I use Google Maps, and I will show how to use Google Maps and get the GPS coordinate and put it in Stellarium to be able to simulate the and this is an application that you can use. This is optional, but it shows it has some really great features. Even it calculates your exposure time. It has some screens that you can see where the Milky Way is going to be in the night sky with the surrounding and the foreground. But it is paid, so it is up to the user. And like I said, you can use Stellarium or other free applications for your cell phone or for your mobile device. And for Moon, like I said, we have to watch moon phase before we go. While we are planning, because I have sometimes received DMs saying that I went somewhere to shoot Milky Way and I see that it is there is the full moon. What am I going to do? And my answer will be, you cannot do anything. you can just shoot moon, or you can just shoot a nightscape with moonlight. You cannot shoot Milky Way during the full moon. But the ideal moon phase is, of course, the new moon, when you don't see moon at all. It is not illuminated by sun at all. So this will take 1 or 2 days, and right after the um, new moon, there will be very thin crescent moon. So that will still work to go. And you can also shoot the week before and after the full moon. And before the full moon, the moon will rise very late at night, like 3, 4 a.m., towards the morning. So you can use these times, the times before moon rising, and of course, right after full moon, um, after a week, 1 week after the full moon, it will again. Sorry, I mixed it up. Before the full moon, there will be crescent, waning crescent, and the moon will set very early in the evening. And after the full moon, before the new moon, moon will rise very late in the night. So you can use those times before the moon rises or after the moon sets to shoot Milky Way photography. And we don't go the few days before and after the full moon and during the full moon. If you are not going to shoot nightscapes with or full moon shots. And even for moon shots, the full moon is not preferred because during the full moon, the moon is illuminated totally, and there are no shadows on the craters. So it will be very plain without any shadows. So even if you are shooting moon, you have to pick these before and after the full moon stages. Light pollution. There is a light pollution classification. It is actually written by a guy called John Bordell, and there is the scale changes from 1 to 9, where 9 is very bright light pollution, and you can only see the brightest planets, and you can only see the brightest few stars in the sky. So you have no chance shooting Milky Way. And Bortle 1 is like, there are some Bortle 1s, I would say in the middle of Atlantic Ocean, or there are some places in United States which are resort parks, in New Zealand, in Australia, in Africa, that you can have Bortle 1 skies. And for Milky Way shooting, I would say ideally Bortle 4 and 3, 2, 1 is okay. Even 5 could be okay, but the signal from the Milky Way will be much lower. So we would be choosing Bortle 4 to 1. For this, we will use we will use light pollution maps that I will show you in a minute. And yeah, for instance, you can see one of them. Its web address is lightpollutionmap.info. It will show you the with a light code, color code, and we will go to this website and have a look at it. And checklist. We have to check our camera or cameras, lens or lenses, and if we use adapters for these lenses, the adapters, tripods, batteries, memory cards, headlamps, food and beverages, dressing and shoes, depending on the weather, of course, and others. For instance, you may have some pills to take, or some specific needs that you may have. You have to check. You have to write a checklist, and like I said before, you have to improve this checklist every time. Okay, before going to shooting settings, I want to go on this website. Has my screen changed because I cannot see it?
Yeah, we can see the website.
Okay, so for moon phases, there, as you can guess, there are lots of different websites. This can be used for looking for the moon phase, and you can also find showing the whole month what will be the moon phase. So you can just write your location here. I wrote Ankara because I'm in Ankara. So it is today waxing gibbous 84.2% moon. So it is almost full moon. So we wouldn't be going outside for this, for shooting Milkyway nowadays. We wouldn't go anyways because there is no Milkyway at this moment. And I will also turn on the stellarium. And for light pollution map, this is the light pollution map that I use. It is light pollution map info. As you can see, there is a light code, and warmer the color, more light pollution there is. For instance, I live in Ankara, and I live in Gölbaşı. So here, as you can see, I am right in the middle of very, very bad light pollution. So if you click on this map, and you will see, this is ridiculous because this cannot be brought to one. There's something wrong with this. Let's pick this one. Yes. So it doesn't show, but we can see from the color codes. So the warmer the color, it is there is more light pollution, and as you go colder and as it goes black or gray, there is less light pollution. When we are planning, of course, we have to look at this. As a Milky Way rises from east and then goes to south. When you're planning Milky Way shooting, for instance, I live in Ankara. If I want to go shoot Milky Way, it doesn't make any sense to go somewhere north of Ankara because the Milky Way will be rising on the east and south. So there will be a huge city with very big light pollution that will make me impossible to see Milky Way or shoot it. So, for instance, if I want to go, I always go Milky Way shooting from home somewhere here to south. So, as you see, there are only small towns and villages in the south. For instance, if I go somewhere like this, for instance, here, this is a very interesting lake. It's Salt Lake. So if I go somewhere here and shoot Milky Way, there will not be any bright city, uh, uh, big city, which will ruin my Milky Way photography. So we have to be careful with that when we are planning to go. And there are also, like I said, light pollution map um, applications that you can use in your cell phones. And there's another light pollution map called darksidefinder.com. You can also use this one, whichever you like, but I like this one better. And Stellarium, it is already open on the other screen, and I will share it with you soon. You can find it in stellarium.org, and it is free for Linux, macOS, and Windows. And you can also use it in web because there is Stellarium web version. But it is free for your computer, so you can download and use easily. Yes. Okay. And sorry. And for weather, I use this website, and this also has a very nice application when you can use on your phones. You can just type the address. For instance, I live in Gölbaşı and Ankara, Turkey. It will, or you can just write the GPS coordinates, and you can get forecast. For instance, let's have a look, and it will show you a week. So, see, from today to next Wednesday. So you can plan the coming week when you can go or you cannot go for astrophotography shooting. For instance, let's have a look at Sunday. As you can see, we see that it is waxing gibbous moon. It is 99%, so it is almost full moon. But let's say that it was the new moon. So we are looking at here total clouds, low clouds, medium clouds, high clouds. You can see the percentage of different types of clouds. For instance, let's have a look. 16th Sunday at 7 p.m. There is going to be 73% total clouds, which is actually low clouds. And as you can see here, it says it's red. So it says don't go. You cannot shoot. And you'll see also the ISS passover time. ISS will be passing somewhere between 20 and 21. And as you can see, at 9 p.m. it clears up totally. So it's green. So it says, and it stays green all night long. So you can go outside and shoot if there was no full moon and if there was Milky Way. And then you can see visibility and fog and patient type, and there is nothing, and probability of rain or snow, amount of rain or snow, and wind speed and direction. You can see chance of frost. There is chance of frost at this time of the year here in Ankara, and you can see the temperature. It's -2, feels like -6, and this is also very important information. Dew point. This will show us when the dew will start. So, for instance, let's see at 9 p.m. The dew point is -6, and the temperature will be -4. So this means there will not be dew at this time of the night, because if it was colder, -5 degrees colder, it was going to reach dew point and you were going to get dew. And what dew does is it blocks your glass of your lens. So you have to use a dew heater, or if you don't have a dew heater, it's like a strap where you can get some power from a power bank and warm up the lens so that dew wouldn't appear on your lens. And you can see relative humidity. It's important because we don't like humid weather because then it will scatter the light from the celestial objects, and it shows pressure and ozone, which are not very important. So we can use this Clear Outside website or the application to see how the weather is going to be before we leave. And of course, there might be other applications or websites that you like to use. You always have to cross-check the weather with other applications. For that, I use another application called Flowix, and it is available on Androids and iOS devices. And I told you about photo fields that you can use, but it is paid. And you can use lots of different star charts or star applications. And I use this one. It's very convenient, star chart. It is again available for iOS and Android devices. So let's have a look at Google Map, and let's also have a look at Stellarium. So this is Stellarium. First of all, we have to know where we will go, and let's say we will go to Salt Lake to this point. So if you remember, this is the point that we are planning to go. So we are looking at light pollution map. So it is all good. This is like Portal 2. So there is no light pollution, and as you can see, there is no big cities on the south, so we can go and shoot Milky Way here. That's why I click on a point that I want to go, and as you click, you see the GPS coordinate will appear here. So I will copy and paste it on Stellarium. When you go on Stellarium, you will see the night sky and also yes here. So you will see some menu here. So you can choose the location. And now I will go and copy this coordinates and paste it here. And also I will go and copy this and paste it here. So what we have done is we actually went there. We are there now. And we copied latitude and longitude values. And if we know the elevation, we can also add the elevation. And we can give a new name, for instance, Salt Lake. And we can add it to the list. So here we're there, but in present time. So it is January 13th and 7:30 here in here with the local time. But we want to be there in a different time where the Milky Way will be. So let's go to 2022 June, and this is May, June, let's say, okay, 13th of June. But as you can see, 13th of June, at this time, it will be still day. So let's go 2022. And so we are now in Salt Lake at June 13th. And now we will see what sky will look like at that time. And I will just remove atmosphere so that we can see Milky Way better way. And as you can see, we see the Milky Way here. So it will be between southeast and south. So you can see the arch will be starting from this point. So when you are there, you have to face to this direction and shoot Milky Way. But of course, there is moon at that time. You also have to plan that. That's why let's change. So if it is 1 and let's say 11:30, so there is no moon and the Milky Way will be southeast south direction. And here you can see lots of other adjustments. I will not go into details, but you can play fast forwards to see how it will move during the night, how it will go and set. So you see, it is like 3 a.m. almost. So it started setting on between south and southwest. And we can also use these compass marks to see the degrees if you want more details. So let's see, let's go back. So you can see around 10 p.m. Actually the Milky Way is so low on the horizon that you cannot start shooting yet. And as the time goes by, it will get higher in the night sky. Let's get a little bit faster. So around midnight, you can start shooting Milky Way at this day, at this point, facing 165 degrees. Are there any questions till here?
I don't see any questions yet.
Okay. Okay then.
If
So
anyone has a
this is
question, they can ask it in the workshop live chat, by the way.
okay. Looks like there is no questions. So this is more or less the planning. You have to watch for moon phase. You have to watch for when the Milky Way will be rising, when it will be setting, using Stellarium and also other applications. So part 2 is shooting settings. Just a second, I need water. Okay. So today the second part will be shooting settings. First of all, we always shoot astrophotography with manual settings. We never use a automatic or other settings. We always use manual so that we can adjust everything as we want. We want the full control. And we have to shoot RAW. This is the first rule. Always RAW. JPEG format is very compressed format. And actually, when you shoot RAW, you have to go and use a program like Lightroom, and you have to stretch your RAW file. When you shoot JPEG, actually, the camera and the software inside the camera does that for you. So we don't want camera to do that for us. We want to change everything in our control. So that's why we have to use the RAW format. Not only that, RAW data has a lot more information than JPEG, compressed JPEG files. And I'm sure even for street photography or other types of photography, everyone is shooting RAW, and then post-processing it. And for night shootings, for Milkyway astrophotography, we always prefer automatic white balance because actually white balance is not an information written on raw files. So once you shoot at any white balance setting, when you are post-processing your photo in Lightroom or Adobe RAW, Adobe Camera Raw, or other programs, you can change white balance as if you didn't set it on your camera. So it is best to use white balance automatic when you're going for Milky Way shooting. And diaphragm, or the aperture, we always tend to use the widest aperture because we need as much light as possible coming through our lens. But sometimes, if you remember, if some of you listened to the previous class, equipment choosing, lenses tend to have more aberrations when they are fully widely open. So if you have a lens with f2.8, you wouldn't go and you wouldn't stop down to f4 because you would lose lots of light. But if you have a lens with, let's say, f1.4, and at f1.4, this lens creates lots of aberrations, let's say chromatic aberration or astigmatism. Then you can try stopping down f2 or f2.8 because your lens is already so wide. It will give you a chance to stop down in the diaphragm. But let's say f2 or f2.8, stick with f2.8 unless you're not using a tracking device, which will give you more exposure time. And shutter speed, we have two rules to calculate the shutter speed. As Earth rotates around itself, we will see the celestial objects are like moving in the night sky. But actually, they're not moving, but we are moving. If you shoot, let's say, 30 seconds with a, let's say, 20 millimeter lens, you will see the star will start trailing. It will be like a line. It will be like an arch. And we don't want that in our photos because we want our stars to look pinpoint. Otherwise, it will not be a good astrophotograph because the stars will be trailing, and that will be a star trailing photo actually. So we have two rules. One of them is 500 rule. This rule is quite easy, and it is actually the time equal to 500 divided by focal length. So if you have a 20 millimeter lens on a full frame camera, 500 divided by 25, so you will have 25. So that means that you can use 25 seconds of exposure without having any trails. But we always tend to go down from that value. For instance, if you have something like, for instance, there is a sample here. If you have a 24 millimeter lens, and if your camera is Nikon APS-C or Canon APS-C, then you have to multiply focal length by 1.5 for Nikon's, 1.6 for Canon cameras. You will have, let's say we have a Nikon APS-C camera and 24 millimeter lens. So it will give us 13.8 seconds. I would rather, run down this number to 12 to be on the safe side as shutter speed. But if you're using a very wide lens, like something like 10 millimeter or 8 millimeter, then this number will increase and it will give you more exposure time without having trailed stars. And the other rule is MPF rule, and it is more strict rule because here, as you can see in the 500 rule, only focal length and the crop factor is involved. But in MPF rule, the diaphragm, pixel pitch, and focal length is involved. So this will give us a lot less, but a lot accurate shutter speed than 500 rule. And pixel pitch is sensor width divided by number of pixels along the length times 1000. So you don't have to calculate this all the time. If you use an application like photofills I mentioned before, you can calculate the shutter speed using that application. For instance, we have here Nikon D610 used with a 24 millimeter lens at f1.4. And as you can see, 500 rule will give us 21 seconds, and MPF rule will give us 4.5 seconds. So there is huge difference. Actually, MPF rule is more reliable one, but within 4.5 seconds, it's really hard to collect enough photons to create a good photo. If you don't have a tracking device to increase this, or if you cannot bump up the ISO, then it is good to use 500 rule and rounding this down, like somewhere like I would say 15 seconds or 16 seconds. And let's see, here again, we see if you stop down to f4, the 500 rule result is not changing because it has nothing to do with the diaphragm value. But MPF rule, as you can see, the exposure shutter speed increases, but now we are losing photons from the diaphragm value. So all this is a game because we need as many as photons as possible, and we have two variables. One of them is diaphragm, and the second one is exposure speed, shutter speed. So we have to use the optimum shutter speed and optimum diaphragm to collect as many photons as possible. So you can see here, if you go crazy with the shutter speed, you will see that your stars will look like a line. So we don't want this. We want this, pinpoint stars. So if you go crazy with the shutter speed, like maybe 30 seconds, 40 seconds, 1 minute, without tracking device, your stars will look like this. But if you stick with the 500 rule or MPF rule, or use a tracking device, you will have pinpoint stars like this. And let's come to ISO. If you remember in the previous class, we mentioned the ISO performance of the camera. In digital photography, the ISO is not a real variable. It is just a digital amplification of the resulting photograph that was created in the sensor. So when you are bumping your ISO from 100 to 200, you're not increasing the size of the pixels, or you're not increasing the number of photons hit on your sensor. You're just increasing, you're just amplifying the light digitally. Amplifying the light, you're just amplifying the digital numbers, and you're making it twice as big. So we have to be careful depending on our camera's ISO performance, especially if we are using a crop censored cameras and old cameras, the ISO performance will be low. So we have to use lenses with lower apertures, wider apertures, and of course we should use the maximum shutter speed to collect as many photons as possible. And we can, of course, bump up the ISO accordingly. But if you're using a modern camera, like a full frame camera with high ISO performance, you can bump up your ISO without any problems. You can use really high ISO settings when you're shooting Milkyway. And we have to watch histogram while we are shooting. After the, when you're testing your Milkyway shots, you have to go and check your histogram. Histogram is a graph shows the distribution of light throughout the pixels. So this is like distribution of from 0, which is pitch black, to white, total white. We can have different histograms like this, and we have to watch and we have to learn how to read the histogram, because when you're using the screen of your camera, you will never be able to understand if you are overexposed or if you are underexposed. So that's why we have to use histogram. So we will have here some samples. For instance, we are looking at this picture. Without even looking at histogram, we can say that it's really evenly distributed light. Maybe there is only a little bit of in these dark places. Maybe we can think that there is underexposed parts here, and maybe we can say that here or here there are some overexposed parts. To understand if there is a overexposed or underexposed part, this graph is taken from actually the Lightroom program. If you click on these triangles, it will show you if there is an underexposed or overexposed part. For instance, here the triangles are clicked, but there is no overexposed or underexposed um, part of the photo. So this, if you have a histogram like this is well can be used, and this can be called as exposed to the left histogram. And from this photo, you can have a really good astrophoto, well-balanced astrophoto with this kind of histogram. So let's have a look at the second one. And here you can see a little bit different. Still, there is not much underexposed parts, and there is no overexposed parts. So let's see which part of the histogram refers to which part of the photo. For instance, let's have a look at this part. So this wall here on this histogram shows the pitch black. So this part of the histogram shows the parts of the photo from here, maybe a little bit of here, and here is the shadows. This part is the shadows, so this will be the shadows. This part of the histogram refers to this part of the picture. And let's look at this part. So it's the midtones. For instance, this could be the midtones, and here this could be the midtones. And as you can see, this histogram doesn't lean on the right wall, which is total white. So we can say this photo also has no pixels underexposed or overexposed. We can say it is again nicely distributed light, and you can have a nice photo out of it. And let's have a look at this one. So we are seeing the core of the Milky Way, and also the raw PUC Antares and raw PUC region, and this is also called Dark Horse Nebula. So when we see this in our computer screen or in our camera screen, we could say that this looks like a little bit overexposed, right? Because here I'm looking at, it's all white, but I'm looking at histogram. I don't see no pixels on the right wall, you see? And in Lightroom, if you click this triangle, if there was an overexposed part of the picture, that part was going to be highlighted, and you will see it in a moment. So this one is still very nice histogram, and this is called ETTR, or exposed to the right. It is used most of the time by experienced astrophotographers because there is high signal in this picture. If you know how to post-process this one, you will get lots of details because there's lots of signal in this picture. And again, now we are looking at the opposite. Again, the same region, but as you can see, there is a very nice histogram, but exposed to the left. But you don't see any pixels leaning on the right wall, left wall. So there is no underexposed pixels, and it is on a little bit of on the shadows part, but still an experienced astrophotographer or photographer will be able to create a great photo out of this one. And let's come to different examples. For instance, here we have almost a full moon, and the reflection of the moonlight on the sea, and there are some really dark areas because they are on the shade, so they are not illuminated by the moonlight or by any other type of light resources. And when we start looking at histogram, we will see that some part of the histogram is leaning on the left wall. So this part is actually here and here and here, representing this part and the histogram. So when you click on this triangle, you will see where does this refer to in the picture. And here you can see very little, something like line on leaning on the right wall. And this shows there are pixels that are overexposed, and we can openly see that this part and some of this part is overexposed, and these parts are underexposed. So when we click, we can see the red parts here in this histogram refers to very bright part of the moon and the reflection. So these pixels are totally white. So that means that they are overexposed. You cannot receive any details from those pixels. They are only white. So, or in other words, actually, if you remember the previous lesson, we were talking about pixels in the sensor. They are like wells. These wells are totally flooded with photons. So that pixel about the maximum value that it can have. That's why there are no details in these pixels. And let's have a look at the left-hand side, left wall. And it is shown with blue here. So these parts, so these blue parts in the picture is underexposed. They are totally black. So no single photon hit to sensor in this part of the picture. So their value is 0. You cannot bring any detail from these pixels. If you try to stretch this histogram towards right, then you will see not details, but only noise will be coming from these parts of the picture. So this can be used also for other types of photography. When you're post-processing a picture like this, that you should know that you cannot get any details, but you can only get noise from these parts. Because when there is no signal is the light that we want, we should know that there is only noise. If you are planning and wanting to have a picture like this, a very high contrast, and you want to have whites and blacks, and you want to have this dramatic view, then of course this histogram is correct. But as you cannot shoot Milky Way with moon, for Milky Way photography, this histogram is not good. But like I said, you may want to have a silhouette of a person or of a hill or an object in your Milky Way photography, then this histogram is correct for you, for your purpose. But normally, we wouldn't want, if we don't want pitch black areas in the picture or whites in the picture, it is not correct. But if you are aiming such photo, then it is your call. And let's go and have a look at this one. Anyone can say that there are lots of parts in this picture which are underexposed, and as you can see, the histogram is leaning on the left wall, and there is not much even data in the shadows, midtones, almost nothing, maybe here, and bright part, highlights, there is nothing. So let's click on the triangle and see what's going on. So as you can see, there's so many parts of the picture which is underexposed. So if you want to post-process this one, and if you want to stretch the histogram towards the right, then you will see that lots of noise is coming along with these blue parts. And overall, it is very underexposed photo. So if you have a photo like this, and let's say you have f2.8 lens, and let's say it is 24 millimeters on a full frame camera, full frame body. So let's say you used 20 seconds 20 seconds of exposure and f2.8 diaphragm, and let's say 1600 ISO. So this shows you cannot open your diaphragm because you're using it at the maximum, and you cannot go up with the exposure time. Then your stars will start trailing. So what you need to do is increasing your ISO. You can go up to, let's say, 3200 and see where the histogram goes, and most probably it will go somewhere like this, and then you can decide to go up with the ISO or keep it like that. Or another option would be shooting the foreground and night sky separately using very long exposure times, like minutes exposure times, and then with low ISO so that you can have details in the foreground, and then you can have a tracker, or without a tracker, you can use high ISO and normal exposure time to sky, and then you can composite these two photos together. So it is like manually made high dynamic range photo. So here we have the opposite. Example. There was a light here when this photo was shooting. It was a headlight or something like that. So we can see here we don't have any blacks. You see, there's nothing leaning on the left wall, but we see there's lots of total white pixels, very enlightened pixels, and a little mid-tone pixels over here and here. So if we click on the triangle, we will see which parts of the photo is overexposed. So you can see this red parts are total white. So this pixels got the maximum value that they can get. So they are totally white. So if you stretch this histogram towards left, you will never be able to receive any details from these pixels. But for instance, you will receive some details, some ripples of the sand here, but you will not see any details here because it's totally white. So it is saturated with photons. So again, if you're not aiming a photo like this, this histogram is not usable for astrophotography. And we are done with histogram. So we use the maximum number of diaphragm, the wide open diaphragm, to get maximum light through the lens, and we calculate the exposure time with 500 rule or MPF rule, and use ISO according to our ISO performance of our camera, and according to diaphragm and exposure time we can use depending on our lens and camera. And these are the settings that we can say general settings. We are most of the modern DSLRs and mirrorless cameras has a function called long exposure noise reduction. In astrophotography, we are always using at least 10, 15, 20, 30 seconds of exposures. When you're doing that, you're hitting the sensor, which will cause thermal noise. To avoid that, we can turn on the long exposure noise reduction. What this function will do is, let's say you are shooting 15 seconds exposure. Once the camera shoots the 15 seconds exposure of the foreground and the night sky, it will close the curtain and will take another photo, which is actually the photo of the sensor. And the software within your camera will subtract this second one from the first one, and your resulting photo will have less noise. So you can see when the long exposure noise reduction off, you will have much more noise. But once you turn it on, you will get less. You can do this manually also, especially if you are stacking Milky Way shots. I always advise to shoot dark frames and use them while you're stacking. But it is not a subject to this class for the moment. Only I can recommend not to use long exposure noise reduction if you are shooting in sequence. For instance, if you are shooting a sequence for a time lapse, it's better not to use noise reduction on, because it will ruin your sequence, and your camera will actually not know what to do, because let's say you will tell your camera take 15 seconds exposures and put 2 seconds between them and take another 15 seconds. But if you turn your long exposure noise reduction on, this will tell your camera, take 15 seconds and close the curtain and take another 15 seconds. So, the camera will not know what to do, and the sequence will be ruined. And of course, even though we are using our camera on a tripod, once you click on your shutter, there will be some vibrations, and micro vibrations may ruin your shot. That's why it is good to use around 3 or 5 seconds of self timer. So the shutter will be released 5 or 3 seconds after when you hit the shutter, when you release the shutter. And final setting is focusing. Focusing can be really tricky. That's why, if you remember, equipment choosing class, we mentioned that it is good to have a camera with a tilting screen and, of course, a live view. So we use live view for focusing generally. So when you set everything and you want to make the adjustment for focusing, you have to point your camera and lens to a bright night object. This can also be planets, for instance, Jupiter or Saturn. They are most of the time very bright, and you can digitally zoom in the live view so that the star or the planet will be big. And if you are out of focus, the star will look like this. And then you will start turning your focusing ring, and you will see, I will play the video. Oops, sorry. As you play with your focusing ring, you will see the star will get smaller and smaller and smaller. At certain point, most of the lens, when you arrive to infinity, it will go a little bit further, and you will see the star will get smaller and smaller and smaller, and after its smallest phase, it will get a little bit bigger. So the exact focus is where the star is smallest. So we want to find that find that spot on our lens. So let's watch again. See, it will get smaller, 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 and it is small here. If he goes a little bit further, you will see it is smaller, and the other stars also started to appear. And he went a little bit further than the infinity point, and star or the planet got even bigger again. So it was out of focus. So when he goes back to that point, see, it is the smallest, and you can see the other stars, because these stars are faint stars. When they are not in focus, you cannot even able to see them. When you're seeing these faint stars, that you are in focus. See, the main star that we picked is the smallest, and we can see the other stars pinpoint. So we achieved the good focus. So some of the lenses has focus locking. If your lens has an option like that, you can lock the focus so that you can accidentally touch the focusing ring, and you can ruin it. And maybe you can shoot all night out of focus, and you can realize when you get home. So to avoid that, you can use the focus lock, or if you don't have, or your lens doesn't have that option, you can use a tape to fix your focus point, not to have surprises. Yes, and thank you very much for listening to me. I think it has been an hour or a little bit more than that. I would like to answer questions if there are any.
Yeah, we did have a question.
Okay.
So the question is there a perfect position of the Milky Way?
Well, is there a perfect position? It really actually depends on you, and depends on your desired composition. But during in of course northern hemisphere, June, July, August, September, you can get the Milky Way in a very good position. But for instance, if you want to shoot, let's say, Milky Way as an arch with a panoramic shooting, you should better pick earlier times of the season, like maybe March, April, and May, because Milky Way will be lower in the night sky. But if you want Milky Way like an arch starting from south to north, and you want it to be right on top, then it is better to pick times like July or August, because then in the middle of the night, the Milky Way will be right on top of you. So using a stellarium, you can decide, you can go to anywhere you want on Earth, and you can go to any time and day. You can see, and you can see Milky Way position at a given time, given day, and given place, and you can set your composition accordingly. I don't know if it answers the question.
Yeah, I think that did. And I don't see any other questions so far. If anyone has one, feel free to type in chat right now.
I have a question for you.
Okay.
Um, is there a temperature range? Is it too cold or too hot? I know you had talked about humidity, but is there ever a time that you need to worry about the temperature as well?
Yeah, actually there's kind of, but anywhere on Earth, during the night, it will not be like 40 degrees, right? So there's not much worry about the temperature. Only the temperature. But if there is high humidity with temperature, then it might be a problem. The problem with temperature could be, I mean, if it is cold, it's okay, but you don't get cold during the summer, during the Milky Way season. But for instance, nowadays it's like most probably it should be around -5 degrees centigrade to -10 degrees centigrade. If you can bear the cold, it is good for camera, because the sensor will not heat like during the summer, and this will cause you less noise in your picture. So the cold is nice. We wouldn't like the high temperatures, but it won't get extremely hot anyways during the night. And with humidity, the humidity in the atmosphere will scatter the light coming from the celestial objects. So we don't want it. And I forgot to tell something. We prefer or we like, of course, you can shoot Milkyway photos in the sea level, but we don't really like, because the first 2,000 meter of the atmosphere has the most dense substance, matter, and dust and water vapor. So this will affect our photography, and it will not look nice if we have lots of humidity between us and Milky Way, I would say. So we prefer higher places with less humid and colder weathers.
Very good. Thank you for that extra information.
Yeah, you're welcome.
All right, thank you, Mustafa, for
You're welcome.
for
I
doing
really
this.
hope it's useful, and I would like to receive feedback from the viewers afterwards if it was useful. If they have questions that I want to ask anytime, my DMs are open always.